Welcome back to our rational functions unit. We're going to continue on in chapter 8. This is unit 5, adding and subtracting rational expressions. So that's our goal for this lesson, to be able to add and subtract rational expressions and to simplify them as well. Have these targets ready for tomorrow, please. Okay, let's start out with some more simpler type problems. Those problems having like denominators. Like denominators is the same as adding and subtracting fractions, normal fractions with like denominators. If they have like denominators, then we just add or subtract the numerators. So for instance, for the first one here, it's really just 1 plus 2 over 3x squared, which is 3 over 3x squared, or just 1 over x squared, because the 3's cancel. Over here we have 4x over x minus 2 minus x over x minus 2. That's just 4x minus 1x over x minus 2, or 2x, not 2x. 4x minus 1x is 3x over x minus 2. Okay, so if they have like denominators, it's pretty straightforward, like normal addition and subtraction of fractions. So you're probably thinking to yourself, well, it can't be that easy all the time, and you're right. You've added or subtracted fractions, but they don't always have like denominators. So when you have unlike denominators, here's what we're going to do. Step 1, factor all numerators and denominators completely to find a common denominator throughout the whole problem. So in this problem, 1 over 3x squared plus x over 9x squared minus 12x. These are not like denominators. So let's go with the steps that we have here. It looks like on the left side, 1 is factored and 3x squared is factored. So I'm just going to rewrite those. Nothing more we can do with those. Same thing with the x. Well, how about 9x squared minus 12x? If I look, they both have a common factor between 9 and 12 of 3. Okay? And they both have a common factor of x. So we're going to factor out a 3x. And that leaves us with 9 divided by 3 is 3x. 12 divided by 3 is 4. And then x factored out. So here is our completely factored numerators and denominators. So we need to get a common denominator from between both of these. That entails multiplying each denominator and numerator by something to create this common denominator. So we look at the left side. Over here on the left side, we have a 3x squared. There's a 3 already in the denominator on the right, so we don't have to multiply by 3's. This side has an x squared, this side has an x, we'll deal with that in a minute. But what's missing from this side, from the right side, 3x minus, is a 3x minus 4. If I can have a 3x minus 4 over here, we'd be closer to having common denominators. So how do I manufacture that? Well, what I do is I multiply by 3x minus 4 over 3x minus 4, because 3x minus 4 divided by 3x minus 4, that's just 1. And we know from way, way back, if you multiply something by 1, it stays the same value. Okay? On the right-hand side, we do the same idea. We kind of discussed that already. We both have 3 on the bottom. We both have an x, but on the left side, there's an x squared over here. This is just an x. What would we multiply x by to get x squared? We get it multiplied by x. So I'm going to multiply the top and the bottom of this right side fraction by x, because x divided by x also equals 1. So we're going to manipulate each side of the equation, and we're going to add this stuff together. So on the bottom, our new one and only denominator is going to be 3x squared times 3x minus 4. On the numerators, well, we distribute 1 times 4, negative 4, 1 times 3x, that's 3x minus 4. And we get x times x, that's x squared. So we end up with x squared plus 3x minus 4 over 3x squared times 3x minus 4. Maybe we can do bottoms up with the top. Can we do our a times c, what adds to make b? I can already hear the groans from home. But yeah, these problems, there's a little bit of work to do in each one, isn't there? So what multiplies to make negative 4 and adds to make 3? Well, what multiplies to make negative 4 and adds to make 3 is negative 1 times 4 and negative 1 plus 4. Those work out. So we get x minus 1 times x plus 4 over 3x squared times, that's cube, but squared, times 3x minus 4. And we do that factoring just in case there's something we can simplify and cancel out. We see in this case there isn't. So either answer will work, either one will work. This is the factoring one, we'll circle that. And that's our answer. We've now added those fractions and created one fraction. Remember, when you're adding or subtracting fractions, your goal is to end up with this one fraction answer at the end. Okay, so adding and subtracting, finding common denominator. We'll do one more here just for a little bit extra practice on this. I know you want to see it one more time. X over 3x minus 15 minus 2x plus 2 over x squared minus 4x minus 5. We're going to factor each piece. X doesn't have to be factored. 3x minus 15, I can divide each of those by 3. And the result on the inside is x minus 5. Over here, 2x plus 2, I can divide both of those by 2, and I get x plus 1 as a result. And I can do bottoms up with x squared minus 4x minus 5. What multiplies to make negative 5 and adds to make 4, or negative 4, excuse me, we x minus 5 times x plus 1. And there is the factor form. Now, before we move on and start multiplying each side, try and reduce, the goal is reducing these fractions as well, or simplifying them as we go. If you see here on the right hand side, this is its own fraction, 2 times x plus 1 over x minus 5 times x plus 1. I can reduce or eliminate that x plus 1 from the top. And so I would end up with x over 3 times x minus 5 minus 2 over x minus 5. And why did I do that? Well, that just made my life a lot easier for getting common denominators. What's the only thing that's different between the right-hand denominator and the left-hand denominator? The only thing different is on the left I have a 3 in front of x minus 5. That means I'm multiplying by 3. On the right I'm not. To rectify that, we're going to multiply the numerator and denominator by 3. And then I end up with x times 3 times x minus 5. One denominator minus 2 times 3 is 6. And that's my answer. One denominator, we did 3 times 2 is 6. That's where the 6 came from. It's all over one denominator because now we're going to have 3 times x minus 5. Can't reduce anything else. That's it. So in this lesson, I believe we showed how to add and subtract rational expressions just like adding and subtracting fractions. It's the same idea. And we also incorporated simplifying those complex fractions into the equation as well. So I'll have these notes ready for tomorrow, and see you in the morning.